We see electrical circuits everywhere. The computers or mobile devices that we are using to watch this video, the cars that we drive, and even the clock that sits on our wall. When we designed some of these analog circuits, we got to meet some specifications. Let us say what is the current that is needed to light a bulb at a given time. And to do this, we have two options. We either calculate it by hand or use simulations to design the circuit and understand the overall response. Performing manual calculations using Kirchhoff's current laws and Kirchhoff's voltage laws work very well for smaller circuits. But what if we want to understand the current through a specific motor of a robotic arm which is doing picking and placing of an object? This is where simulations help a lot. In today's video, we will understand how we can build and simulate electrical circuits using MATLAB. Let's start by designing a simple resistor, inductor, and capacitor circuit, which is an RLC circuit. We'll begin by opening Simulink. Now the first question is, what are the components that we can model? We would have to check these using library browser. We can go to Simscape, Foundation Library, and select electrical. Let's first add a resistor, a passive component, and say add block to the model. We see that the resistor is added to Simulink. Similarly, we add an inductor and a capacitor. Now, one thing you will notice is that the passive components also have a plus minus sign. These are just to show the direction of the current that's flowing through them. Once we have added the three components, we can specify the parameters for each of these elements. For resistor, you can specify the resistance value. To begin, let's set the resistance value to 10 ohms. Similarly, for the inductor, we can set the inductance value, and for the capacitor, we can set the capacitance value. We can also set some initial targets for the inductor and the capacitor. With that said, the next step would be to add a voltage source. We can go to Library Browser, Foundation Library Sources, and select the source that we want. There are multiple ones, but what we need is a DC source, which is a battery. We connect it to the components. We also need to give a ground reference. And then we just need to let Simscape know that it has to solve this task. So we add a solver configuration block and connect it to the assembled circuit. And we're done. Let's run the simulation and see it running. So we would want to understand how to measure the current and voltages across the elements. For this, we could use sensors. So let's add a voltage sensor across the R, L, and C component, and a current sensor as well in the circuit. Also, we want to visualize it, so let's add a scope. However, we see that the scope block is not getting connected to the output of the current sensor. That's because the current or the voltage sensors have outputs which are physical signals. Now, the physical signal needs to be converted to a signal using the PS to S block, which is the physical signal, the signal block. And there we have, it's connected to the scope. We can then run the simulation for different values of R, L, and C and check the performance of the circuit to understand if it's an underdamped, overdamped, or a critically damped system. We can visualize the data and inspect the details of each of the signals across and through each component. Now, RLCs are not the only components one can model. We could have models with AC voltage sources as well as current sources. We could also have diodes, op-amps, MOSFETs, three-phase systems. We can also use them to understand the characteristics of these devices. We can go from designing diode rectifiers to designing and simulating a synchronous JK flip-flop. If you would like to learn the basics of simulating electrical circuit using the Simscape tool, which we saw in this video, be sure to check out the 2-hour self-paced course on the circuit simulation on-ramp.